In our previous module, we discussed functions. We'll see our first example today in our discussion of linear functions. Basically, a linear function is just a function that describes a line. So a linear function, so we can say a linear function is a function that can be expressed in the form f of x is equal to mx plus b. So here b is called the vertical intercept and m is called the slope. So basically linear functions have a slope and a vertical intercept. Sometimes the vertical intercept is known as a y-intercept. And you might be familiar with the vertical intercept as a y-intercept, but sometimes the dependent variable is not always necessarily y, so we'll just be variable neutral and call it the vertical intercept. Now this is called the standard form. So this equation up here, I'll call it star. So star is the standard form. So mx plus b, basically y is equal to mx plus b. So let's take a look and see what this looks like. So we have f of x equals mx plus b. So if we were to graph this, so we write y is equal to f of x, or y is equal to mx plus b, we see that the y-intercept would be b, and then we get a graph that looks like that. And then the slope of this line is just equal to m. So what that means is that if I take any x value like this and look at a second x value, so we get a small delta y and then a small delta x, that this ratio, delta y over delta x, will always equal m. So it doesn't matter which 2 points we pick, any 2 points, when we compute the change in y divided by the change in x, we always get the slope. So in other words, the slope is always equal to y2 minus y1 divided by x2 minus x1. So in this case, it would be x1 and x2, and the y value here would be y1, and the y value here would be y2. So basically the slope is the rise over the run, or the change of y over the change of x. Now this leads us to a second form to describe a linear function. So this is the so-called point-slope form. So the point-slope form, you're given different things. So you're given a point on the line. So we'll call that point x0, y0, and the slope. So given a point on the line and the slope, we can figure out a formula for the line by just simply thinking about the slope. So the slope is always the change of y over the change of x. So it's going to equal y minus y naught divided by x minus x naught, where we're leaving y and x unspecified. But any point on the line has to satisfy this equation because the slope is always going to be the same. So therefore we can just solve this equation for y to get a new form. And that is y minus y0 is equal to m times x minus x0. So this is called the point-slope form, and it's another way of describing a line. So if you have a point on the line and the slope of the line, you can come up with an equation just by using this. So for example, find the line that passes through, say, the point 2,8 with slope m is equal to 3. Okay, well this is going to be y minus 8 is equal to 3 times x minus 2. And notice it's just y minus y naught is equal to m x minus x naught. So I just took the point that I was given, which is the point 2, 8, and I inserted x is equal to 2 for x naught, and 8 for y naught, and then the slope of 3 and for m. And so I have the equation like this. And we can add the 8 to the other side, and we see it's equal to y is equal to 3x. So this is 3x. We distribute the 3. 3x minus 2 plus 8 would be 3x plus 2. And we can check that this is indeed a line with slope 3. As we can see, the x coefficient is 3. And then at x is equal to 2, we get 2 times 3 is 6, plus 2 is 8. So it satisfies all the requirements. And that is the point slope form. Sometimes we're given data that appear in a table. So 1, 2, 3, 4, 2, 3.2, 4.4, 5.6. So we can infer that this is a linear function because for every change in x, the y values change by exactly the same amount. So f of 1 is equal to 2, f of 2 is equal to 3.2, f of 3 is equal to 4.4, f of 4 is equal to 5.6. So if we look at the delta between any two, delta y is always equal to 1.2. Between 2 and 3, delta y is equal to 1.2 again. 4.4 minus 3.2 is again 1.2. And between 3 and 4, delta y is equal to 1.2. 5.6 minus 4.4 is just 1.2. So whenever the x value changes by 1, the y value is changing by 1.2. Right? So for each of these, the delta x was equal to 1. So the slope is going to be delta y over delta x, which is just equal to 1.2. So to come up with an equation for this linear function, we just use the point slope form. So we can, for example, use just the first point. We have a pair of 1, 2. So y minus y naught is equal to m times x minus x naught. So we replace y naught with 2. The slope was 1.2 times x minus 1. So in other words, y is equal to 1.2x, then minus 1.2 plus 2, so plus 0.8. And that is the function that we are looking for.